Welcome to this explainer. Today, we're jumping straight into a topic that quite literally affects every single person on Earth. We are going to demystify the environmental effects of climate change. But, instead of getting caught up in all the usual noise and debate, we're just going to look directly at the undeniable source data and the realities happening right outside our windows. We're keeping it focused, we're sticking to the science, and we're going to see exactly what the weather is trying to tell us.
So, if you felt lately like something is just fundamentally wrong with the weather, you're definitely not alone. I mean, just look at 2019 as a prime example. In late winter, you had 14 different U.S. states, stretching all the way from North Dakota down to Louisiana, completely smothered by historic flooding. And that's the kind of flooding that usually only happens in the spring. Then, exactly 1 month later, a massive, severe winter storm just slams the high plains. Think about that for a second. A devastating winter storm happening right in the middle of spring. Fast forward to April and May, and you've got this terrifying outbreak spawning over 500 tornadoes across the Central Plains. It's like these extreme weather events just keep coming at us. They're getting bigger, and they're happening way more often.
Okay, let's dive right into this. Section 1, extreme weather right now.
Because here's the thing, this chaotic weather isn't just a localized fluke hitting a few unlucky states. This is a massive, global reality happening everywhere, all at once. Over in Japan, they had a heat wave in May with temperatures soaring over 100 degrees Fahrenheit. Down in Western Australia, they baked through their warmest January on record, topping 120 degrees. And honestly, this next one is probably the most startling. The Atacama Desert in South America, which is literally known as one of the driest places on the entire planet, actually flooded. So from Japan to South America, this intense, bizarre weather is hitting everyone.
Which brings us to Section 2, the science of warming.
Let's move to the data and see how this builds, because within the scientific community, there's actually zero debate on the core fact: the planet is unequivocally warming. The globe is warming from the top of the atmosphere all the way down to the bottom of the oceans. And it's so important to understand that this science isn't some modern political invention, right? It's a proven physical reality discovered over a century ago. Back in 1859, an Irish scientist named John Tyndall figured out that certain atmospheric gases trap heat. 40 years after that, in 1899, a Swedish scientist named Svante Arrhenius predicted that burning fossil fuels would boost that exact warming effect. And from the 1950s all the way to today, NASA's satellites and our modern instruments have just been tracking exactly what those two scientists predicted. They hit the nail on the head.
And the core mechanism they identified back then? That's what we now call the greenhouse effect. It's simply the process where carbon dioxide, methane, and water vapor trap heat in our atmosphere. It's a pretty elegant, inescapable piece of physics. When you pump more of these gases into the air, more heat gets trapped. Simple as that.
Now you might be wondering, how on Earth does a warmer atmosphere equal catastrophic floods? Well, you kind of have to look at our planet as a giant water world. Step 1, global heat increases. Step 2, because our world is mostly water, that extra heat evaporates way more ocean water up into the sky. And step 3, what goes up must come down. The result is heavier rainfall worldwide. It's a brilliant analogy that perfectly explains why we're seeing massive floods and intense rain even in places that are supposedly drying out.
So let's look back. Section 3, decoding the climate past.
Now, what's really interesting about this slide is how it answers a question we all hear all the time. Hasn't the climate changed in the past? Isn't this just a natural cycle? Well, scientists can actually look back in time, way before thermometers were even a thing, using what they call climate proxies. Tree growth rings can show us wet, dry, hot, and cold periods going back hundreds of years. Ice cores drilled out of ancient glaciers actually contain trapped, ancient bubbles of the atmosphere from hundreds of thousands of years ago. And ocean sediments, they let us map the climate millions of years back. And when you combine all these paleoclimate models, the forensic evidence proves definitively that our current warming is completely unprecedented. It just can't be explained by natural forces like sun cycles or volcanoes. It is driven strictly by emissions. When scientists talk about the global temperature changing by just a few degrees Fahrenheit, I know it sounds incredibly small, like maybe you don't need a jacket today. But look at this stark contrast. If the Earth is just a few degrees cooler globally, boom, we're plunged into a deep ice age. But if it's just a few degrees warmer, we get a greenhouse Earth where crocodiles are literally swimming up near the North Pole. A couple of degrees globally is a massive amount of energy that completely reorganizes the entire planet.
So the crucial point is the simple, undeniable correlation found throughout all of deep history. It's basically the golden rule of the climate record. Lower carbon dioxide means lower temperatures. Higher carbon dioxide means higher temperatures. It's a rule that has been unbroken for millions of years.
Let's bring this a little closer to home. Section 4. Your city in 2080. If we take that historical rule and fast forward to see what it actually means for us, researchers created this incredible future urban climates mapper. It compares 540 different urban areas, bringing this abstract global data right into our backyards. By the year 2080, Washington, D.C. is projected to feel exactly like Greenwood, Mississippi does right now. That means winters are going to be 10 degrees warmer and a staggering 75% wetter. Kids growing up in D.C. today might literally have to convince their own children that it ever used to snow there.
And it's definitely not just D.C. Run the clock forward 60 years, and Miami is going to feel more like southern Mexico. Minneapolis-St. Paul, that'll feel like Nebraska. St. Louis and Denver will feel like northern Texas. Putting it this way really takes that abstract 2 degrees of warming metric and makes it incredibly vivid, relatable, and local. The climate is moving in these directions right now.
Which transitions us to Section 5, the human cost.
Because these shifting weather patterns do a whole lot more than just change what kind of clothes we buy. They create this profound domino effect on our global ecosystems and our societies. Look how fast things are changing. In just the 25 years between 1990 and 2015, the ideal planting zones for agriculture have marched drastically north. The heat is moving, and our plants, the absolute foundation of our food system, are having to pack up and move right along with it.
And we see these shifts threatening our fundamental day-to-day systems. Out west, droughts are worsening, which is skyrocketing the risk for these terrible wildfires. In the Midwest, huge upticks in heavy rain are literally wiping out crops and making it impossible for farmers to even plant their fields. And across the South, extreme heat is just expanding and lingering longer. When nature shifts this dramatically, it hits our food supply, our supply chains, and our economy right where it hurts.
But the ultimate human stakes here go far beyond just the natural systems. As our source material notes, and I'll read this quote directly, large-scale drought is going to force people to migrate. That's going to destabilize regions, and we're going to have climate migrants. This is about human societies reacting to resource scarcity. The impacts are going to be massive, rippling across the entire planet.
All the data, the extreme weather, the migrating crops, the ancient ice cores, it all brings us right here, to this one very dramatic number, 415 parts per million. This is our current atmospheric level of greenhouse gases. The overwhelming scientific consensus tells us that unless the world can bring these levels down, we really need to brace ourselves for even more life-changing extreme weather events. The urgency is right there in the numbers.
So I'll end today with this lingering, provocative thought. Is this really our future? The science is incredibly clear, but the outcome relies entirely on our understanding of it. I highly encourage you to talk about this data, ask questions, and really look into how personal actions impact the planet. Arm yourself with this information and share what you've seen here today. Thank you so much for joining me for this explainer. Stay curious, and I'll see you on the next one.